Join me as I dive into some mind-bending real-time travel experiments that blew everyone's minds, and I'll see if I can recreate them myself. Time travel has long been a topic of fascination, with many of us wondering what it would be like to journey through the ages, witnessing historic events firsthand or meeting people from the past. Real-life experiments have taken place that challenge our understanding of time, and it's these experiments that we'll be exploring today. Time travel poses significant scientific challenges, particularly when it comes to overcoming paradoxes. If a time traveler were to go back in time and kill their own grandfather before he had children, then that would mean the time traveler was never born. But if they were never born, who killed the grandfather? This creates a paradox that has puzzled scientists and philosophers for decades. The laws of physics as we currently understand them do not allow for time travel, at least not in the classical sense. According to Einstein's theory of relativity, time dilation occurs when an object approaches the speed of light or is placed in a strong gravitational field, causing time to pass more slowly for that object relative to a stationary observer. However, achieving such speeds or gravitational fields is far beyond our current technological capabilities. Technological limitations also pose a significant barrier to time travel. Even if we could somehow manage to create a stable wormhole or alter the fabric of space-time, the energy requirements would be enormous, possibly even exceeding the energy output of a star. The technological challenges are so great that many scientists believe time travel, if it's possible at all, is still centuries away. Theoretical models of time travel often rely on exotic forms of matter and energy that have yet to be observed or proven to exist. These models are highly speculative and are the subject of ongoing debate in the scientific community. While they provide a framework for understanding how time travel might work, they are still far from being tested or confirmed. Physicists have conducted experiments that manipulate time in small ways, such as the quantum entanglement experiments, where particles become connected and can affect each other even at vast distances, seemingly instantaneously. The work of physicists and projects like the CERN Large Hadron Collider has also led to discoveries that challenge our understanding of time and space. Researchers have used advanced technology to create closed time-like curves, which are loops in space-time that could potentially allow for time travel. These curves are still purely theoretical and are based on complex mathematical models. The implications of such discoveries are profound and have sparked intense interest and debate in the scientific community. One notable experiment involved the use of atomic clocks to test the effects of time dilation. By placing one clock on a plane and flying it around the Earth, scientists were able to measure the difference in time passed between the flying clock and a stationary one, confirming the predictions of relativity. This experiment demonstrated the real-world effects of time dilation and has significant implications for our understanding of time and space. A specific experiment that produced unexpected results was the delayed choice quantum eraser, which showed that the act of observation can retroactively change the behavior of particles, even after they have been measured. This experiment has sparked debate about the nature of reality and the role of observation in shaping our understanding of the world. The results of this experiment have been replicated and verified, but the implications are still not fully understood. They challenge our classical notions of time and space, suggesting that reality is far more complex and interconnected than previously thought. The delayed choice quantum eraser has opened up new avenues of research into the nature of quantum mechanics and its relationship to time. The delayed choice quantum eraser experiment has also raised questions about the potential for time travel or communication through time. While the results do not provide a direct method for time travel, they do suggest that information can be sent through time, at least in a quantum sense. This has significant implications for our understanding of causality and the flow of information through space-time. In summary, time travel experiments have challenged our understanding of time, from the manipulation of atomic clocks to the creation of closed time-like curves. These experiments have sparked intense debate and interest in the scientific community, and while they do not provide a clear path to time travel, they do offer insights into the nature of time and space. Join the conversation and leave your thoughts in the comments about time travel. And if you're interested in more mind-bending scientific topics, be sure to check out our other video on the mysteries of black holes.